Good day, grade 12 learners and teachers. Welcome to today's mathematics lesson. My name is Mr. Shongwe, and this lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Right, welcome back, good people. You've been in a short recess. I know most of you have been keeping on working, so please ensure that you leave no stone unturned. Now we're going to be looking at revision of a few concepts. So we have a revision series. We would have part 1 of paper 1, part 1 and part 2 of paper 2, and then we would have the final preparation of paper 1 as well as the final preparation for paper 2. So this is the first of the revision series, and today we are going to be focusing our attention on number patterns as well as sequences. So now remember, we are looking at the distribution. Remember, we always say and emphasize that you should be setting up those targets. They are very, very important. Target per topic. So as and when you practice a specific topic and you are looking at past exam papers for that specific topic, you go also and check whether you are meeting that particular target that you've set yourself. So please ensure that the target setting is kept alive, and then you are tracing whether you are meeting those required targets, so that if you are not meeting them, then you can interact with your teacher so that they can intervene when it comes to that. Now when you look at the table there, you can see that all the topics are outlined, and in each topic there is a minimum target as well as a target for a bachelor pass. So our minimum target for the topic that we'll be doing today would be 12 marks out of a total of 22 to 28 marks. That is the number of marks, the range for the number of marks that you find in that topic. And then if you want a bachelor pass, then you should be aiming at 15 out of the total number of marks that are available there. But remember, good people, if you can get more, always strive to get more marks in each topic. Right. Now, obviously, you'll be given an information sheet which must be fully utilized so that we don't make unnecessary mistakes. So now, if you check on this particular slide here, you can see that the topics, or rather the formulae that we are going to be utilizing today are encircled. You can see that we've encircled these formulas there. These are the formulas of focus for today's lesson. So we'll be looking specifically at these. These are the formulas that govern patterns and sequences. So these are the formulas that we use for patterns and as well as sequences. So it's important that you keep that in mind and fully utilize the table. Remember, when you look at sum to infinity, you are also given there a condition for which the series would converge, and this condition will therefore permit or allow us to use the sum to infinity if the series is actually convergent, because this is utilized for what? For a convergent geometric series like that. It is for a convergent geometric series. Right. The objectives for today: by the end of this lesson, you should be able to revise the quadratic patterns, to solve problems involving quadratic patterns, to use formulae for arithmetic and geometric, solve problems involving quadratic, arithmetic, and geometric sequences, as well as arithmetic and geometric series, solve problems involving arithmetic and geometric series, or use the formula for the series, understand the concept of convergent, and solve problems involving the sum to infinity. Right, we can obviously refer to the CAPS guideline there, or the exam guideline as well, on the pages that are prescribed. Right. Now, the pre-knowledge that you should be bringing into this lesson, it's patterns that were learned earlier on. The algebra is useful also there, the number systems. If they tell you that determine the number of terms and you get that it's not a natural number, then you should be rejecting one of the solutions. So in order for you to do that, you need the knowledge of the number systems. Now, also word equations, literal equations, logarithms and exponents. You should be able to calculate n if you are needed to calculate n there using the geometric series formula. So it would demand of you to also at times make use of exponents or make use of logarithms. Right. Approach to questions, very important. We must read and understand the question scenario. Read more than once. Don't just read once and jump the gun. Please read more than once. Try to understand what the question demands of you. Underline the key terms like linear, arithmetic, geometric, first term, constant difference, common ratio, etc. Those are the most important terms that we use in this topic. Now, you should be able to interpret questions, extracting key and write down, extracting key information and write it as a pattern or a sequence. Naming terms such as Tn, showing the type of a sequence or a series that you are dealing with. And you should be able to correctly select a formula that you can use from the formula sheet to suit a specific sequence that is given to you. And you should be able to substitute in that formula and solve. Right. Quadratic number patterns. Let us look at the concept that governs quadratic patterns. Now, a quadratic pattern is one where the second difference is linear, or the first difference is linear, so to say, and the second difference is constant. So it is governed by a linear first difference and a second difference, which is constant. So the first difference form what we normally call an arithmetic sequence in grade 12. So please do keep that in mind, that the first difference of that quadratic number pattern can be treated as any arithmetic sequence that you've been treating this year. Now, the general term or the nth term is in the form. Obviously, it is a quadratic, so it should be governed by what? By the basic quadratic form there, or the basic quadratic form, or the quadratic function. So please also remember that since this is governed by a quadratic form, this can have a maximum value or it can have a minimum value. Keep that in mind, which means you can infuse aspects of calculus as well here to get the maximum term or to get the minimum term. So you should always keep that in mind, because at times they can ask you questions like, show that this number pattern will not have a value exceeding maybe 60, for an example. So if you show that 60 is the maximum, then you can say, because 60 is a maximum, it implies that there is no term that would be greater than 60. So you need to keep that in mind as well, because quadratic patterns are they follow what the quadratic function does, so which means that you can have a minimum value or a maximum value. So you need to be very, very careful of that as well. Now, by using the general term, we can actually put n to be equals to 1, so that to get the first term, put n to be equals to 2 to get the second term, put n is equals to 3 to get the third term, which means we can work out T1, T2, T3, T4, etc. by substituting n with 1, 2, or 3 as we go. So now if we are to do that, this is what we obtain. Can see T1 is A plus B plus C, T2 is 4A plus 2B plus C, T3 is 9A plus 3B plus C, T4 is 16A plus 4B plus C. Now, if you are to write that in a Patinic form, you are to see that this is what you have. You have T1, you have T2, you have T3, you have T4. If you are to work out the first difference, you can see that this is 3a plus b, 5a plus b, 7a plus b. So you can see all the terms are increasing by what? By 2a. So 2a becomes what now? The second difference. Because to move from 3a plus b to 5a plus b, you add 2a. To move from 5a plus b to 7a plus b, you add 2a. So we can now see here that this becomes the first difference, this becomes the second difference, which means that this is the first term of the second difference, this is the first term of the first difference, this is the first term of the original pattern, like that. So now, note, the first difference will always form a linear pattern. The first difference always forms a linear pattern like that. Now, and the second difference is given by the expression 2a. It's constant, 2a. So even if you are to work out another one here, it will be 2a. Another one there, it will be 2a as you go on. So NPN is the position. It is always a natural number. So the understanding of number systems here becomes of paramount importance to say n is an element of all natural numbers. So it cannot be in decimal or fraction form. Right, obviously you've done this in grade 11, you've revised this in grade 12. So now we are going to be looking at some prelim papers, starting with our province, and then we're going to be exploring other provinces as well. We are looking at prelim papers for 2024, and we are going to be focusing on patterns. So now most of the work would be done by you because you've done a lot of practice to this. You've just written your prelim. So now I am going to give you the first activity to run through, and this activity is for about 8 marks. So I am going to give you about 6 minutes to quickly work on that. I think 6 minutes would be sufficient. Please quickly work on that particular question, and your 6 minutes time starts now. Right, hello and welcome back. Let's look at how you were supposed to actually solve this particular question. I hope that you were able to do it. It's one of the questions that was in your prelim paper. Right, let's start with the first one. Write down the fourth term of the sequence. So you can see this is the first term, this is the second term, this is the third term. So we need term number 4. And our term number 4 should be 27. So you should be looking at the first difference and looking at the second difference. Because if you are to check 0, 5, 14, and so on to 779 and 860. If you are to check here, the difference is 5. If you are to check here, the difference is 9. And then from there, it shows that because they said it is quadratic, this would be 4 like that, which means that the difference here also 4. And then 9 plus 4, you will get 13, which means that to move from 14 to the next term, you'll be adding 13, so that would be 27. So that would be your T4. That is why here we wrote it as 27 like that, and it's 1 mark, so you'll get that 1 mark for actually attempting it that way. Now moving on, we need the expression for the nth term. So we work out, you see now, we've worked out the fourth term and the fifth term, and then we've worked out the first differences, and we've worked out the second differences. So now we want an expression for the nth term. We remember that we said when we started, this is 2a, this is 3a plus b, and this is a plus b plus c. So we are going to be utilizing that to formulate the 3 equations that we will therefore, if we work out the value of a, b, and c, then we can substitute that into our Tn is an squared plus bn plus c like that. So now our 2a is equals to 4. Just like I indicated, when you divide by 2 both sides, you get that a is equals to 2. And then our 3a plus b is equals to 5, just like I mentioned here. But because we now know a is 2, we are going to substitute a as 2. And then from there, we solve for b, and then we get that b is -1. And then moving right along, we should be coming to this one now. A plus b plus c 0. There we go, a plus b plus c 0. And then from there, we substitute a as well as b. And then we solve for c, we get that c is equals to -1 like that. So now we have the value of a, the value of b, and the value of c. And then we can write down our nth term like that. So you are, because this was for 4 marks, you will get a mark for value of a, value of b, value of c, as well as the expression. So you are able to get the full 4 marks. Here you are able to get that 1 mark there. Right, let's move right along. The last question here says, calculate the number of terms in the sequence. Calculate the number of terms. So we want to know how many terms are there in the sequence. So if we know what the last term is, remember this is the last term. So if we know what the last term is, to calculate the total number of terms here should not be a problem, because we want the position. So we want the position of the last term. We are interested in the position of the last term, so we will know how many terms are there in the sequence. So we are going to take our nth term and substitute our Tn. Our Tn is 860, and then we solve for n. Right, let's check. This is the general formula that we derived in the previous slide. And then from there, we substitute where we see Tn, we put 860. And then from there, we write it in standard form, which means that we are going to be transposing the 860. So we will have -1 minus 860, which gives us -861. Now, this is quadratic. because this is quadratic, we can solve it using either inspection, or we can use the quadratic formula, or we can actually solve by using the method of the completion of the square, like that. So now we just work out the factors using inspection. The factors of 861, that will give us -1 there would be 41, because we also looked at the factors of 2n squared, that would be 2n and n, and then the factors of 861, that would be 41 and 21, like that. So now this shows us that n should be -41 over 2, or n is 21. But remember, we said n should be an element of what? It should be an element of natural numbers. So we reject this one because it's a fraction. Remember, n represents the number of terms, or the position of that particular term. So it cannot be a negative number. So now from there, we conclude that n is equals to 21, which means that there are 21 terms in this particular sequence. So that's how you were supposed to work out that particular question. I hope that it makes sense. I hope that it makes sense. These are marks that are easily accessible to you, but please make sure you understand the concepts there. Right, I move on. Now, in moving on, I have now another quadratic number pattern, and this one is laden with what? With unknowns. So this one I will solve it with you as an example. We want to solve for x and y, and we are given a pattern and they said it is quadratic. So because it's quadratic, we will work out the first differences, work out the second differences, but we know the first difference is linear, the second difference is constant. So if we know the second differences, we'll know all the terms in the second differences should be equal, because that is the concept that governs quadratic number patterns, right? Now let's see. See, now we took the pattern as it is, we've worked out the second difference is x minus 2 gives us x plus 2, x minus 2 gives us x plus 2, 8 minus x gives us 8 minus x, like that, 19 minus 8 gives us 11, like that, and then y minus 19, these two, y minus 19 gives us y minus 19, like that. So now to work out the second differences, this one, how do we obtain it? We say 8 minus x minus x plus 2. So this would give us 8 minus x minus 2. So negative x minus x gives us negative 2x. 8 minus 2 gives us 6. That's how we got to that one. And then to get to this one, we said 11 minus into 8 minus x. Remember, you are subtracting a binomial, so the use of brackets here is of paramount importance. So you should be using those brackets. Now, when you apply the distributive law, minus 8 plus x, like that. So now what happens is you'll get that 11 minus 8 should be 3 plus x. That is how we got to that difference. And then the third one, we are going to be taking this one, subtract that. So you have y minus 19 minus 11. So this y becomes y, like that. Negative 19 minus 11 is negative 30. And then we write it like that. Now, these are our first differences, and these are our second differences. And we know the second differences are constant, which means this is equals to that, which is equals to that. So that is what we are going to be using to solve for x and solve for y. So first we will equate 6 minus 2x is equals to 3 plus x, and then this will give us now the value of x. Then from there, after knowing the value of x, then it will be easy to work out the value of y. We can equate these two as well there. So now let's see. See, the first thing we did was we equated the first differences. 6 minus 2x is equals to 3 plus x, as I indicated, and then we solve for x there. So transposing this to the side gives us 3x, and then this to the side 6 minus 3, which gives us 3, like that. And then from there we get that x is equals to 1. So solving for that, we get that the value of x is equals to 1. Now that we know the value of x, we can equate these two here. Then we can work out x. You see now 3 plus x is y minus 30. Remember, it's also okay to equate this one with that. You equate one expression that contains x with another expression that contains y. Because you've worked out the value of x already, then you'll be able to substitute. So substituting that value of x allows us to then solve for y. We get y is equals to 34. This question was for 4 marks, which means that working out the first differences is a mark, working out the second differences is a mark, and then from there calculating the value of x and calculating the value of y, and then that gives you a total 4 marks for that particular question. Right, we move on. I believe we've done enough as far as quadratic patterns are concerned. So it's up to you to practice more of these quadratic patterns and see the other variations and the way in which they can ask the other questions like that. So now we move on to arithmetic sequence and arithmetic series. Now, the first thing that we're going to do here, we are going to look at the governing concept that actually govern arithmetic sequences as well as arithmetic series. So we are going to remind you of those concepts. Now, starting off with arithmetic sequence is a number pattern in which the first difference between consecutive terms is constant. Now that's the expression there, and Tn is the general term. And then to find the difference, the constant difference, you subtract T2 from T1, T3 from T2, T4, T3 from T4, I should say. So you subtract T1 from T2, T2 from T3, T3 from T4, Tn or Tn minus 1 from Tn. That would give you the difference there. So that difference is known as the constant difference. And then the general form to that is Tn is a plus n minus 1d. That is the general form of that particular linear or arithmetic sequences. Remember, sometimes this is called what? It is referred to as the linear sequence. It's the same as that. So now we look at the series. Remember, the series is the answer that we get when we add. So an arithmetic series is formed by adding the terms of an arithmetic sequence, which means if you have an arithmetic sequence 2, 4, 6, 8, 10, and so on, to make this a series, you are going to add these terms like that. So you are going to add the terms that make up what? An arithmetic sequence. So that is an arithmetic series. Now, looking at that, we can calculate the sum of n terms of an arithmetic series by using the formula. See, if you want to calculate the sum of n terms of an arithmetic series, you can make use of that formula there, right? And if the last term is given, if L is in the series is given, that is the last term, then the formula can have a variation. Sn is n over 2 into a plus L, like that. Remember, the derivation of Sn formula is examinable. The derivation of this formula is examinable. So you should be able to derive this formula. It is examinable. So please ensure that before you get into that exam, you are able to derive that particular formula, because they can ask it for 5 marks. And it's part of a book work. It's marks that you should be getting without any hassles there. Now, let us move on to the concepts that govern the geometric sequence as well as the geometric series. Now, geometric sequence is a number pattern in which each consecutive term after the first term is found by multiplying the previous term with a non-zero number called the common ratio. So if you have A and you want to move on to the next term, you multiply by the ratio R. You want to move to the next term, you multiply by the ratio R. You want to move to the next term, you multiply by the ratio R, which means that this becomes AR squared, AR cubed, and so on. So that is what happens. You multiply by a non-zero number called the common ratio or the constant ratio, like that. So now if you have that as your terms, then it means that in order to get the ratio itself, you divide T2 by T1, you divide T3 by T2, and so on. Right, the general formula in this one is in that particular form. Remember, this is in the formula sheet. In the formula sheet, it is contained within our formula sheet. That's very important. Now, a geometric series is formed by adding the terms of a geometric sequence. So to form a geometric series, we add terms of a geometric sequence. If you have, say for an example, 2, 4, 8, 16, and so on as the geometric sequence, as the geo sequence. If you want a geo series, then you add these terms like that. You add these terms, then you form what we call a geo series, a geometric series like that. So now let's look at the formula. We can calculate the sum by using the following formula. The first formula now is this one. And the second formula is this one. Remember, R cannot be equals to 1. It's a fraction, so it contains that natural restriction that if R is 1, it means we'll be dividing by 0. And dividing by 0 is undefined, right? So now, the second formula is normally easier to use when R is less than 1. So when your constant ratio is less than 1, then it is much more advisable to use the second formula. So please make sure that you use the correct formula. Remember now, here these formulas are derivation, the derivation of this formula, derivation of Sn formula like that is examinable. It is examinable. Good people, I indicated we should leave no stone unturned. So it's important for you to practice those derivations. They are examinable. They may be in the exam. So please make sure if they are there, you are able to pick up that 5 to 6 marks. It will be part of what we call book work. So please make sure you prepare yourself thoroughly for that one. Right. Now, let us now move to the sum to infinity. Remember, we've just looked at a geometric series. So sometimes when you add the terms of a geometric series, like this one, when you add these terms of a geometric series, 2, 4, 8, 16, because the series becomes bigger and bigger, the terms are becoming bigger and bigger, which means the sum becomes bigger and bigger. And we say that that particular sum is diverging because we cannot predict what it is because it is becoming a very big value. As you multiply with a constant ratio, the terms grow bigger, the sum grows bigger. So we say that we have what we call a divergent series. It diverges. However, if now the constant ratio becomes smaller or the terms become smaller and smaller, say for an example, you have 8, 4, 2. You can see that the common ratio here, R is equals to what? Is equals to half. So 2, 1, this becomes smaller and smaller. So as these values of the terms become smaller and smaller, what happens is that when you add all the terms, the sum approaches a specific value. So we say that the sum now converges to that particular value. So the sum will converge. Remember, with the other one, I said it becomes bigger and bigger. So we get that the sum now diverges as opposed to what? To converging. So now, if the sum converges, then we can calculate the sum to infinity. But there is a condition. Your R should be following, or it should conform to a specific condition, right? Now, a geometric series will converge. There is that condition. It will converge when the sum approaches a specific value. If the constant ratio is the number between -1 and 1. So we can see here that R should be trapped between -1 and 1. And this half here meets that condition. So that is why I said the sum will then converge to a specific value. As you add more and more terms, what you add always becomes a bit negligible because the sum maintains a specific value. If the sum converges to 5, no matter what you add, it makes just a minimal impact because the sum is what? It is converging. Right. So now, as we move on, but remember the condition for convergence, R should be trapped between -1. Now, for the convergent geometric series, this is the condition. It should be known. It is there in the formula sheet. It is there in the formula sheet. Now, the value approached by a convergent geometric series is called the sum to infinity. So whatever value that it approaches or converges to, it is called the sum to infinity of that geometric series. We can calculate the sum to infinity of a convergent geometric series by using the formula. So this one is a derivation. Derivation is not examinable. The derivation of this one includes the use of limits that you are using in calculus, because we have to limit this specific sum to a specific value there. So if we try to limit it from the left and from the right, then we can be able to derive that particular formula, because we'll be using the approximations to say as n gets to infinity, this gets smaller and smaller and hence becomes a bit more negligible. That is how you derive that one. So the derivation is not actually examinable, but the formula is available in the formula sheet. Right, now there's an activity. I've just given you the concepts. Now I want to give you an activity to do. Let me just check with my activity here. Okay, fine. Now, I will just give you just 2 minutes to complete this one. Just 2 minutes. I think 2 minutes would be enough for you to be able to complete this activity. And your 2 minutes time starts now. Hello and welcome back. Right, let's look at this question. I hope that you are able to solve this with ease. So you want the value of P for which TP is 430 and you are given an arithmetic sequence. So that's very important. You know the sequence is arithmetic. So you want P when TP is 430. So they are trying to show you here that they are using, instead of N, they are using P. So this should be A plus P minus 1D. So that's just what we're doing there. We're replacing N with P. So let's look at the solutions. There we go. So where there is N, normally we put P. So now if we are to substitute there, TP is 430 and the value of the common difference, if you subtract this from that and this from that, there you get that this is 5 and this is 5. So you have 60, 65 and 70. See, to move from 60 to 65, that's 5. 65 to 70, that's 5. So that constant difference there is 5. So now if you are to substitute, where there's TP, you put 430. Where there's D, you put 5, and then you solve for P. Now you distribute the 5 here using distributive law. So you get 5P minus 5. You get that 60 there as it is. And then from there, you are going to then put the P, leave the P on one side. 60 minus 5, that is 55. You transpose that 55, you get 375. You divide both sides by 5, you get that P is equals to 75, like that. So that's how you were supposed to work that out, and that is just for 3 marks. So you get a mark for substituting, and then you get a mark for simplifying, and then you get the mark for the answer there. So that 3 marks, you get the 3 marks easily like that. I hope that makes perfect sense. Now let's move on to another one. This one, the sum of the first 3 terms of an arithmetic series is increasing arithmetic series is 30, and the product, you are told that this arithmetic series is increasing. That's very, very important. This word increasing here is very, very important. And then the series is 30, and the product of the same 3 terms is 510. Determine the value of A and D in the first term and the common difference respectively. This is from, together with the previous question we've just done, this one, they are both from Eastern Cape prelim papers. So, it's an Eastern Cape prelim paper 1. So now, I want you to take about 4 minutes, because this question is for 5 marks. So I'm going to give you about 4 minutes for you to quickly work out the solution to this interesting question. This is very interesting, so it will challenge you a bit, but I have faith that you'll be able to solve it. So I'm giving you 4 minutes, and your 4 minutes time starts now. Right, hello and welcome back. Yeah, let's look at this interesting question. Let's see how you were supposed to solve it. The sum of the first three terms of an increasing arithmetic series is 30, and the product of the same three terms is 510. Determine the values of A and D, the first term and the common difference. So you can see the unknown is the value of A and the value of D. So there are two unknowns. So now our key aspect here would be, if we want to solve for A and D, let us then write down the first three terms. Let us write them down in terms of A and D. So the first term T1 is A, T2 is A plus D, T3 is A plus what? Plus 2D. Which means that if they are talking about the sum of the first three terms, we'll be adding T1 plus T2 plus T3. So you'll be adding A plus D, A plus 2D. That would be the sum. And then they say, and the sum is 30. They've given you the sum is 30. And the product of the same three terms is what? 510. So you'll now be multiplying T1 times T2 times T3, and then you should be getting what? 510. So that would give you the two equations. The first equation would be derived from the sum. The second equation would be derived from what? From the product. So from those two equations, when you solve them simultaneously, you'll be able to get the value of A and the value of D. Right, let's check how you were supposed to go through that one. Now, the first one is the sum. You can see I've added T1, T2, and T3. Added the 3, and then we get 30. And then from there, after adding those, we get that A is common. A plus A gives us 3A. D plus 2D gives us 3D. That's equals to 30. And then we can formulate an equation. If we divide by 3, we get A plus D is 10. And then we know that then by transposing D, A is equals to 10 minus D. That is our numerical equation 1. Right, moving right along. The product now, T1 times T2 times T3. That is the product. It gives us 510. So now what we can do is we can substitute. We already have equation 1 where A is written in terms of D. So where we see A, we can then substitute what? 10 minus D. So if we do that, we can see this was the A, it was replaced by 10 minus D. This was A here, it was replaced by 10 minus D. And then this is A here, it was replaced by 10 minus D. A there, it is replaced by 10 minus D. So simplifying that, we can see 10 minus D plus D gives us 10, and then 10 minus D plus 2D gives us 10 plus D. Dividing both sides by 10, if we divide both sides by 10 here, we can see that we get that this is 51. 10 minus D, 10 plus D is equals to 51. So because it's equated to 51, we can actually apply the distributive property there. We multiply, we get 100, we multiply, get plus 10D minus 10D, and then minus D squared, and then we transpose the 51. So now, simplifying that further, we get 49 minus D squared is equals to 0. And then we get D squared is equals to 49. If we transpose D squared there, then D is 7 or negative 7. Then we take that D is equals to 7. We reject this one. Why are we rejecting this one? We reject this because, remember they said it's an increasing arithmetic sequence. So if you are adding negative 7, if you continuously subtract 7, the series now decreases instead of what? increasing. So that is why we reject this value. We only take d is equals to 7. And if we do that, then a, remember a from equation 1, a is equals to 10 minus d. So where we see d, we put 7, we get that a is equals to 3, like that. So we've worked out the value of d, which is 7, and the value of a, which is 3. So we are done with that. We get the full 5 marks, like that. So moving right along. Now, this one, I'll do it as an example. It's the second example. Given the arithmetic sequence, now it is given in terms of what? In terms of variables. So they say calculate the value of x, determine the 10th term of the sequence, and determine the sum of the first 99 terms. Now, if we look at that, let's check the solutions. For A, determining the value of x, obviously this is T1, T2, and T3. So we're going to use T2 minus T1 is equals to T3 minus T2, and that's what we get there. And then simplifying, we get negative x minus 2 is negative 2x minus 12. Simplifying that further, we get negative 10x is negative 10. Then x becomes 1. Now that we've solved for x, we can determine the 10th term of the sequence. Now, how do we do that? We need to then substitute back x so that we can get our terms as numerical values rather than as values containing variables, and then we can determine the 10th term. Now, let's see. This is the sequence where we substitute x, we'll get the first term is 16, the second term is 6, the third term is negative 4. And then from there, we work out T10. Remember, we are using Tn is equals to a plus n minus 1 d. And we already know what a is. We know what d is, and we know what n is because we are looking for T10. So we just substitute, and then we get that T10 is negative 74. Now the last one, they want us to work out the sum to the first 99 terms of the sequence. So let's go through that. Sum to n terms of an arithmetic sequence is obviously given by n over 2 into 2a plus n minus 1d. It's there in the formula sheet. Now, because we're looking for the sum to the first 99, where we see n, we're going to put 99. Where we see a, we know a is 16 from here. And where we see d, we know that d is 16 minus 6, it's negative 10. So we substitute that into the formula. Let's see, substituting that information there, and then we're going to get that as sum to 99 terms is minus 46,926. Right, that's how you were supposed to work that one out. So I hope that it makes perfect sense. Moving right along. Now, we are given this as the geometric series. So now this should be the next question in line. I am going to give you about 5 minutes to complete those questions as quickly as you can. Just 5 minutes. This was from our own Gauteng prelim paper. It's the geometric series. So giving you 5 minutes, and your 5 minutes time starts now. Right, hello and welcome back. Let's quickly go through the question that I gave you. Remember, this is a question that was in your prelim paper, so we're just reviewing that. So it's like a preparatory exam review. Now let's go through that. Determine the value of x for which the sequence converges. We are given that this is a geometric sequence. Remember, it is only a geometric sequence that converges under specific conditions. So the condition is that R should be trapped between -1 and 1. So in this case, they want that convergence in terms of what? In terms of x. Now, let's see. Now, if you look at that, we first find the constant ratio by dividing T2 by what? By T1. So T2 divided by T1. This is from what? T2 divided by T1. So this gives us the value of R in terms of x, right? So R is x minus 2 divided by 2. So we've expressed R in terms of x. Now, in doing that, we also know the condition for convergence, that R should be trapped between -1 and 1. But now, because R is given in terms of x, we are going to substitute R in terms of x there. So you see, where there is R in this condition for convergence, we've put in that value of R in terms of x. Now this is a compound inequality. With a compound inequality, what we do is we're going to multiply each term by what? By 2. Each term by the denominator 2, so as to remove that denominator there. So now in doing that, we get that -2 is trapped, or x minus 2 is trapped between -2 and 2. And then simplifying that, it means we're going to now add 2, we add 2, so that we isolate x there. So in adding 2 across, we get that x is trapped between 0 and 4. So that is the value of x must be in between 0 and 4 for this series to converge. Now, the second one, they want us to calculate the sum to infinity if x is 2, 5. So what we can do is we can substitute where we see x here, we put 2, 5, and then we generate a series. And then from there, we calculate the sum to infinity. Alternatively, you can calculate the sum to infinity in terms of x, and then from there, later on, substitute the value of x. Now, let's see. Sum to infinity is a over 1 minus r. Now, what I did here was I worked out the sum to infinity in terms of what? In terms of x. So where I see a, I put the first term. This is the first term, 8 into x minus 2 squared. And then where I see r, I put this value of r here. So that's the value of r there. Now, I simplify this by substituting the value of x, which was given as what? 2.5. So if I substitute the value of x, which is 2.5, I get that the sum to infinity is 8 over 3. So that's one way of calculating the sum to infinity. Remember, the other way would be you substitute x first, you generate the series, which is independent of x, which means that the series will only be given by what? By numerical values. And then from there, you get a, you get r, then you calculate the sum to infinity like that. Now, moving on to number 2. Number 2, we are given now the summation. This is the sigma notation. So if we are given the summation, they say how many terms are there in the series, and then calculate the sum of the series. So because this is given in sigma form, what we ought to do is first to calculate the number of terms there, we say n is equals to what? Top minus bottom plus 1. So it will be 12 minus 3 plus 1. So that's how we work out the number of terms in the series. And then to calculate the sum, we need to expand and get the terms. Then we can be able to calculate the sum. Right, now let's go through that. First things first, the number of terms, 12 minus 3 plus 1, as I indicated, top minus bottom. We take the upper index of summation, subtract the lower index of summation, and then we add 1. So now we get that n is equals to 10. So we know that we were adding a total of 10 terms. Right, moving right along to 2.2. Now we are going to expand the series. And in expanding, we can get that the value of a is that a is -6, and then r is -2. After having expanded, you've worked out a is -6 and r is -2, and we know we are adding 10 terms. So because they are geometric, we're going to use that. Remember, we're using the 1 minus r, 1 minus r, and why is that? Because r is less than what? Is less than 1. So now in doing that, we substitute those values there, and we get that the sum to 10 terms is 2046. So this becomes bigger and bigger. It is diverging as opposed to converging. Right, that's how you're supposed to work that out. Right, now let's move on to the next one. Can ignore this one. Let's look at it this way. We've typed 2 of them there, so we've duplicated. So we're going to be focusing on this one. Now, an infinite geometric series, I'm going to take you through this one because we don't have enough time for you to go through it yourselves. An infinite geometric series has the first term equals to 2 and the constant ratio equals to 1/3. Calculate the next 2 terms. You are given the first term is 2, and then the constant ratio is 1/3. So to move to that, we multiply by 1/3. Move to that, we further multiply by 1/3. That's how you get to the next 2 terms. And then we want to calculate the sum to infinity, and then we want to work out the value of m given that particular summation. Right, let's see. The solutions, the first one, obviously the next 2 terms, 2, we've worked it out here. So 2 times 1/3 is 2/3. 2 times 1/3 times 1/3. This is 1/9 times 2, which is 2/9. Those are the next 2 terms. And then we want the sum to infinity. So calculating the sum to infinity, we say a over 1 minus r. So we know that a is 2, and we know that r was given as 1/3. So we substitute those, and then we get the sum to infinity as what? As 3. So this series converges to 3. Right, and then we interested in the last one. Very, very interesting. They want us to determine the value of m. Now, remember here, you also need to check the lower index of summation, because in order for you to get the number of terms here, you need what? M minus 3 plus 1. So that expression, this expression here is very important and will be used later to calculate the value of m, because in our SN formulas, we are given that n value as opposed to what? To m. So you have to be smart about how you approach this. Now let's check. We first expand because we are given the sigma notation. So we're going to expand. How do we do that? We're going to start by substituting 3. So this is 8 into 2, and then 3 minus 1. And then we go 8 times 2 into 4 minus 1. So that's how you expand. So we're going to get 32, 64, and 128, and so on and so forth as we expand. So, but we know that from this a is 32 and r is equals to 2, and we know the sum Sn is equals to 131,040 there, like that. So now we are going to then substitute that into the sum. In doing so, we substitute the 131,040. Where we see a, we put 32. Where we see r, we put 2. And then we want to solve for n. So going on with that, we can then simplify it and get 2 to the exponent n minus 1 is 4096. Transposing the 1, we get that 2 to the exponent n is 4096. Here it was 4095. So from there, we get that 2 to the exponent n. We write this as a prime base, 2 to the exponent of 12. So we get that if the bases are the same, the exponents are equal, then we say that n is equals to 12. Now, after working out n, we know because we are given a summation, top minus bottom plus 1. So n is equals to m minus 3 plus 1. Since we've worked out n already, we substitute that, and then we get that m should be equals to 14. So that's how you were supposed to work it out. It's a very interesting question. Please do go back and practice it once more. Right. Let us summarize the lesson for today in closure. The sequence or the pattern is when consecutive terms are obtained by a certain rule starting from the first term. If the pattern is quadratic, then it will contain the first difference, which is linear, and the second difference, which is constant. However, if the sequence is arithmetic, then it will contain a constant first difference. If it is geometric, it will contain a constant non-zero term called the constant ratio, which you will be multiplying by to move on to the next term. For problem solving, a pattern has to be actually ascertained. We have to ascertain whether it's arithmetic or geometric before we can actually use the relevant formulae. So the value of n, the term number has to be a natural number. So n is an element of what? Of all natural numbers, like that. Thank you very much. Please do join us again next week, where we'll be looking at statistics in paper 2. Thank you very much. Please take care of yourselves, take care of each other, and always practice mathematics. Goodbye.